Hi everyone, welcome to our next lesson. Our next lesson is going to be on some drafting. So I'm going to go over some of the general stuff that's the same concepts for both grade 8 and 9 IA. Some of these things will be specific to grade 8 or grade 9, but they're good to kind of go over for both of you, for both grades. Have an understanding of different tools and concepts that you're going to be getting over the next couple of years. So, the textbook is online. You'll all kind of recognize the blue Drafting Fundamentals textbook that we use in this class quite often with our drafting. And you'll find it online. I've kind of photocopied the specific pages that we do, and I've put it on the Google Drive for you. So feel free to refer to that anytime. You're going to need it when you do some of the questions from the assignments that I've given you already. So a few of the concepts and terms that I want you to understand, I'm going to go over those, and I'll explain some of the assignments separately. Okay? So today, tools. Some of the tools that are very commonly used within drafting are a set square. Okay, so these are two set squares here. We know these as triangles, yes. But the key thing is that there's a square angle. Okay, a 90-degree angle in both of them. Okay, one 90-degree angle on these triangles. Now this has a 30 and a 60, and this has two 45s. And you might say, well, why are these specific triangles important to drafting? It's all about the angles. And we use these angles so much when we draw and design certain projects, whether they're big or small. Okay, a small bedside table or a big house, you're going to come across those angles, 30, 60, 45, 90. Those are those common angles, and so when we make pictures, we want them to be scaled down or scaled up, depending on what we're making, and we want it to be accurate. So the angles will still be the same. The lengths might be different in a scaled drawing, but the angles are important. So that's why we have these set squares, and they help us draft and draw and create pictures. Okay? A compass. Well, we know a compass is for drawing circles. Okay? Arcs, circles, different things like that. Again, within the drafting and sketching process, sometimes we need an arc or a curve, and so a compass is something that we'll use for that circle. There's something called a French curve that you will use for other kind of curves or arcs that are not simply the 360-degree circle. Okay, T-square. So a T-square, this is definitely a little bit more of an old-fashioned tool used in drafting. If you're making building plans, an architect, a sketch of some kind for some kind of a build that you have. Again, big or small, doesn't matter. But a T-square helps keep lines straight. So obviously we've got the horizontal and the vertical, and this has a little bit of a hook on it so that it'll sit on whatever you're doing. And now when I draw this line right here, okay, that line will be perfectly vertical, and it will also be perpendicular to whatever I would set it on. So you could use this on boards if you need to, or more specifically on paper when we're doing sketches. But it's a multi-purpose tool that can be used for a lot of things. The other use that you'll get out of this is sometimes when you're using your set squares, you like to have that straight edge that it's going on. So how do you set it? How do you tilt it on the paper? So this T-square, again, can be used as a starting point to make sure that you're very square to what you want to draw or draft. So now I know that this angle is exactly 45 to this surface. Okay? So there's another use for a T-square. Now we get to some scale rulers. And we know the scale rulers are these kind of three-sided units. And again, they are a scale. So they will scale up and scale down. Not scale down, sorry, but they will scale up. They have a 1-to-1 scale, and then going up from there, 1 to 2, 1 to 20, 1 to 10, 1 to 50, 1 to 5, those different scales. So the 1-to-1 is obviously set to actual millimeters and centimeters. And so if you measured something with a 1-to-1 scale, that would be an accurate measurement straight up. And if you measured it with a 1 to 10 scale, Well, 1 centimeter is actually, so 100 millimeters is actually only the size of 10 millimeters. Okay, so it's 100 times, or sorry, it's 10 times smaller. So that's on the 1 to 10. And obviously if the scale goes as is labeled. A protractor. Okay, a couple different types of protractors that you'll see. This is the most common one. Okay, everyone has that semicircle type protractor, but then we also in the shop will use this circle. Okay, a complete circle here, 360-degree protractor. And that can be very useful when drawing different angles at different sides and coming off of different areas, and a very accurate measurement. If you ever have to do a 270-degree opening, okay, it's easier to do that with one full circle rather than have to do it as 2 parts when you only have 180 degrees on a regular protractor. So there's a protractor. And between the grade 8 and 9s, you'll be kind of using some or all of these tools within your drafting. Okay, how about scales? Okay, we've got different scales that we talk about. Reduced scales, enlarged scales, that's one of the questions that I've given you. 1 to 5, 5 to 1. What's the difference between those 2 scales? So I want you to go through your textbook, and you're going to find within that textbook there is a page that talks about scales. Enlarged and reduced scales. So if you think of the map, okay, a map is a reduced scale drawing. It's taken something in real life, reduced it down to a smaller size to get it onto a piece of paper. A reduced scale. Okay, a reduced scale would start with the number 1. A enlarged scale is something that is smaller, that it's hard to see, but you need to make it larger so that you can put it on a piece of paper to show or diagram it. So the parts of a watch, an old-fashioned watch, not one that's most commonly used now, the digital things, but sometimes when you're looking under a microscope at certain particles or parts of smaller animals, okay, a bee under the microscope and the parts of a bee, the digestive system, something like that, where you need to enlarge it to be able to see it. Maybe a picture of an eye, okay, and a doctor needs to be able to show you the different parts of your eye and what's going on. So instead of having it the size of an eye, they enlarge it. Okay, and so that's what this one would be. This would be an enlarged scale. And so you need to try to understand the difference between reduced and enlarged and how you can relate it to real life. Okay, some very common terms that we're going to get into here. I will challenge you to find some of these in the textbook. There's always examples in there. Center lines. So what are center lines? Center lines are obviously showing you the center of an object. And that's important within the drafting world, within the sketching and architecture and engineering and all that kind of stuff. When you've got a shape and you need to know where that center is, there will quite often be a center line, but a center line is separated by long and short dashes. And that's how you know, oh boy, that's a pretty awful center line, isn't it? Okay, that's how you know where the center of an object is. So it might be easier if I was to use this guy. Long, short, long, short, long. Okay? So you get those dashes that alternate between long and short, and that represents a center line. Sometimes you'll even have maybe a rectangle. Okay? It doesn't have to be a circle. Sometimes you can have a rectangle, and you'll have these center lines marked on. And again, they'll be alternating long and short dashes. That represents a center line. Well, what are dimensional lines? Okay, you'll hear the word dimensional lines. So, a dimensional line is something that represents the length of a side. Okay, so sometimes we will have a 3D shape, and we will want to create some dimension to it. We want to know what the dimensions are. So what is this length? What is this length? What is this length? Okay, so these are going to be dimensional lines. And what you'll notice is that dimensional lines we'll have a number. Okay, so maybe this is 120 feet, and maybe this is 60 feet, and maybe this is 20 feet. Okay, a dimensional line is drawn parallel to the side that it represents, okay, to the length of the side that it represents, and the number will always be placed on the inside of the line unless it's too small. So if I didn't think I could neatly and accurately write this, sometimes you'll see a line like this. And you'll see those arrows pointing in between there. Okay? Here the arrows would be placed here, representing those lengths. So these are dimensional lines used to show you the length of a side. Okay, you're going to have to produce some dimensional lines in some drawings that you do. You're going to have to read some dimensional lines. You're going to have to read dimensional lines and use a scale to produce another picture or a copy of the picture. Now, what's sketching and drafting? Well, sketching is what I'm doing right here. This is sketching. Sketching is freehand pictures. You're just making a sketch of something that you want to build. So maybe this is going to be a house that I build here, and I'm going to have some windows. Okay, I like this here. Got to have a window here, and maybe I'm going to have a door on the back side. Whatever the case is, this is a sketch. It's not to scale. It's not. There's no straight lines. I'm not using a straight edge. I'm not using a protractor or a set square. It's just a drawing, just a picture. Well, then what's a draft? Drafting. Okay, so drafting is more second step, third step, fourth step type of thing when you're talking about creating a picture or a diagram or an example of something you're about to build. You could have sketches of highways, of buildings, of different things you're going to do on some land, okay? And the next level is always drafting, making that good copy. So, the difference between the two is I would start to use a straight edge. Obviously, I wouldn't just go over top of what I did, but within my new copy, I make sure that I've got that nice 90-degree angle in that picture, sorry. Okay, and so a draft, you're going to be using a ruler and other instruments like a compass maybe, a straight edge of some kind. Okay, you're going to measure out accurately. You're going to have a scale to it. Okay, sketching has none of those. So sketching is what we do on a scrap piece of paper or anything, on a whiteboard, where we just try to come up with ideas. And drafting is producing that good copy. So you're going to be asked to do both of these items within some of the questions here. Good copy, rough copy, good copy. Okay? Now, how about orthographic and isometric? We've come across that before. Well, what I have here is one of the two. I'm going to let you try to take a guess as to that before I give you the answer. What is this thing? Is this an orthographic picture or an isometric picture? Okay, so this is 3D. So 3D is our isometric. So this is an isometric picture. An isometric sketch in this case. Well, what's an orthographic? Orthographic is actually 2D, but there's 3 pictures. Top, front, and side. So what does this thing look like from the top? From the top, I can just see these 2 things. So he's going to look like this. There's the top. What's he look like from the front? So here's the front. Well, he's going to look like this. Okay, and then what does he look like from the side? What does he look like from the side here? Just looks like a rectangle. So that thing just looks like a rectangle right there. This is called the orthographic. Okay, this is your orthographic picture. 2D, so I only have a length and a width, length and a width, length and a width, 2 dimensions, versus this one has a length, depth, and height. It's got 3 dimensions to it. These pictures would need to be produced, both of them, to have a complete draft, an architectural drawing, okay? This or this could start your sketch off. You don't necessarily need both, but probably by the end of it, you'd have a rough copy of both. Now, that's the main difference between an orthographic and an isometric, something that you, again, are going to be working with on identifying sides, what relates, what compares, how is this up here, and this over here, how do those relate? Can you pick sides out? Can you match things up? That's part of your assignment. Now, the last one I have here are hidden lines. You will not see hidden lines in an isometric view, but you will see them in an orthographic view. Just like center lines will only show up in an orthographic view. So what are hidden lines? Well, hidden lines are things that are happening in the background that you can't see. So for example, when you're looking at this thing from this direction, it looks like a full rectangle, but over here, it's not. Something's happening. And it's actually dipping down back here. It dips down and over. So how do I represent that? Right here? Dot, 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 dot. Evenly spaced dashes. So, dashed lines. Now this tells me there's something going on the back side of this view. If I wanted, I could have had a look at it from this view. Okay? So this view, I would still be the same height. Everything would look the same, except this would be a solid line now. Okay, so that would be a solid line that you could actually see. It wouldn't be dashes, it would be solid because it's looking at it from here. So it all depends on the view that you're looking from. And that's really important when you're trying to design different things, projects, ideas, okay? Is you want to be able to have a visual picture, be able to see all sides and angles, sometimes even from the bottom, okay? Now, certain shapes are going to look much different from the back side as the front or from the left as the right, but for the purpose of what we're learning and what we're doing, orthographic, 2D, top, front, side. And you'll notice how I laid these out. How this and this always line up with each other. This and this always line up with each other. It's really important. It's not good to do it like this. Okay, so I would not want this picture to have this guy here, and then over here I'll do this guy. Oh boy, that wasn't a very good one. And then over here I'm going to do this one. So these are the same pictures, but they don't match up with each other. They're not the same height, and there's no match here, right? So this is a very hard to read sketch, hard to read drawing. We don't want to do our orthographic pictures like that. We always want them in what we call an L-shaped figure. So top, front, side. Always in that L, so you can see top, front, side. That's always the way you want to mark them out. Use graph paper any chance you can. When you're doing drafts, graph paper will also help you with sketches. It keeps things in line, easy to read, neat. You don't have to do a lot of copies if you do these well. If you're kind of making those mistakes, they're off center, you're hard to read, you're not making sure of things, now you have to do more copies, it's actually more work for you. So this will help you with a little bit less work. Okay, now on to a little bit of your questions. So each class, grade 8, you've got 10 questions to get into the textbook, or it's online, and that kind of takes you between pages 6 and 30. Grade 9s, you've got 9 questions, and they're kind of all over the place. You're going to kind of go between page 6, 7, 20, 32, 34, 173, 176, so all over the place. But it's labeled at the top of your page where to find them. And then each class has different assignments within that textbook, as well as different assignments within the package that I've given you. Okay? Now these are all related and based around the concepts here. Orthographic and isometric are really big topics that we're going through. Understanding the difference between these two and producing some drafts, some drafting, hidden lines, dimensional lines, we get into all of that, but the key is isometric and orthographic. You're looking at pictures, you're comparing, and you are kind of solving problems, okay? So feel free to work your way through some of those questions. What I'll do is I'll give you a couple of days to do that, and then what I'll do is I'll solve some of the questions for you on the board to kind of give you some assistance and help you along. But if you have some questions as you're working through, feel free to email me or contact me through the Google Classroom, and I can help you with some of the answers. Now I know you might not have all these tools, okay, the protractors, the set squares, the scale rulers. So anything that requires those tools, you can put off until we get back to school here in a week or so, and we can do that. So there's lots of work you can do without those tools based on the textbook. Again, it's easier to find some graph paper. I've provided some graph paper in your booklets for most of you. The grade 9s have some tricky sketching to do on 3D paper, and I know you'll have some difficulties with that. My only advice is to use a pencil. Okay, that's key for both of you. Use pencils with everything that you do because mistakes will be made. Erase again. Erase again. By all means, Google some of this. Okay, see if some people if you can watch some videos on how to lead through creating 3D sketches. Okay, they're very tricky when you're first learning. So giving it a go by watching some videos, trying on the paper I've provided, making mistakes, correcting until you get to that final product. So good luck. Like I said, I'll give you a few days to do this, and I'll probably maybe on Friday or Monday give another video of some answers to your questions. Okay? Have fun. Pause, rewind, do whatever you need to do with this video to go over some of the information. Otherwise, have fun.